All right, focus, fellas. I hope you are doing well as you are watching this video. Hopefully you had a good Cinco de Mayo yesterday. Hopefully the weather's nice today and we can get outside. It was a little chilly yesterday. I don't know about you guys, but I don't like that coldness. I want that sunshine back. Today what you're going to be working on is some geometry review. So, with no further ado, let's get into it. So you're going to be doing some classifying. First off, you're going to be classifying different building blocks of geometry. So for example, this first one here, we have a line, and we know that's a line because it has two arrows indicating that it goes on forever in both of those directions. Then we have a ray. We know it's a ray because it has one endpoint and one end going on forever in that direction. And last but not least, we have a line segment, and we know this is a line segment because it has two endpoints. So we'll be doing some classifying of those building blocks, and then you will transfer that into classifying types of lines. So we know that if they are crossing and not forming right angles, that we have some intersecting lines. We know that if they never cross, like these two, that they are parallel lines. And we know if they cross and make right angles, they are perpendicular lines. So you will also be classifying some lines, and then you will apply all of that to an image we have here. And we're going to do some annotating. So we're going to name a set of parallel lines. Remember, parallel lines are those lines that are never going to cross. Just like line SL is parallel. Remember that symbol for parallel to line DO. And then you will notice we need some intersecting lines, and we have a lot of options for that. A lot of these lines are intersecting, so choose whichever one you want. I'm just going to go ahead and go with this guy right here and this guy right here. Notice how they make that X. So I have line IU, and then I'm going to write the word intersects line PT. Like I said, there are a lot of them in this visual that are intersecting. So you could have chosen EW intersecting PT, IU intersecting DO, IU intersecting SL, lots of choices. And then perpendicular, you know how sometimes Mrs. Claire likes to trick you. Do you actually see any lines that are perpendicular here? No is the correct answer. None of those lines are making an actual right angle. Some are close. If I look at EW and PT, it's close, but it does not make an exact right angle. So don't assume that there has to be one. So we actually do not have a set of perpendicular lines, so I'm going to write the word none. Make sure if they are perpendicular, you're getting that perfect 90-degree angle. Okay, makes that perfect box. You're going to classify some angles. So remember, if it is greater than 0 degrees and less than 90, we have a cute little angle. Make sure you're writing angle and not angels. Okay, those L's and E's. If it makes a straight line, well, it's a straight angle. If it is greater than 90 degrees, but it is less than 180, that's when we're going to get those obtuse angles. And last but not least, the ones that make that perfect box, the 90 degrees exactly, no more, no less, that's where we have those right angles. So you will classify some angles. And then you're going to do some radius and diameter review from when we did Pi Day. I know that seems like it was a while ago, but it was only a couple months. So remember, when you have a circle the diameter cuts the circle exactly in half. So if we look at this picture, does that 42 millimeters cut it exactly in half? If you said yes, then you are correct, because that is our diameter. Remember, radius is half the diameter. So to calculate my radius, I need to take half of 42. I'm going to go ahead and show my work here. I know for many of you, you can do this in your head, but it never hurts to show your work, to be able to explain your thinking. And I get 21. Again, don't forget those units. So my radius should be half as big as my diameter, and I can check. Yeah, 21 is half as big as 42. Let's take a look at this one. Do I give you a radius or a diameter in this picture? Well, if you said radius, you're correct, because I did not cut the circle exactly in half. So I gave you a 9.3 or 9 3/10 centimeter for the radius. Now remember, diameter is twice as big as radius, so you have two options here. You can multiply by 2, or you can double 9 3/10. I'm going to go ahead and multiply by 2, and I get 18 6/10 centimeters. So you're going to do some problems with circles. I did not include circumference. That was an enrichment piece we did this year. It's actually not part of your standards as you're learning 5th grade math. It was just something fun we did. All right. Before I go on to this problem, I want to apologize. This image should have 1 line here, 2 here, and 3 here. I apologize. I got a little happy with my copy and paste when I was making that image. So if you could just please correct that for me, I appreciate it. All right, classifying triangles by sides and angles. Remember, sides, we have 3 options. Equilateral, they're all equal. Isosceles, you have 2 eyes, they have 2 that are the same, and scalene is that one that's just different. Looking at this first one, I notice they're all 3 different, so it's a scalene triangle. And then for angles, you have 3 options. If they have all acute angles, they're acute. If they have a right angle, they're a right triangle. And if they have an obtuse angle, they're an obtuse triangle. And I noticed right here, got that right angle, so he is a right triangle. So he is a scalene right triangle. Looking over here at our next one, I notice the congruency marks, 2 of them are the same right here. And I know I have 2 eyes, so he's an isosceles. And if I look at the angles, acute, 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 so he is also an acute triangle. We'll do 2 more. I notice all 3 sides are different, so all different means scalene. I notice right here, that angle is bigger than 90 degrees, so that's an obtuse angle. And then my next one, all the congruency marks are the same, so he is all equal, or an equilateral triangle. And if you look at the angles, they're all those tiny cute ones, so he's acute. All right. Quadrilaterals. Remember, definition of a quadrilateral is a 4-sided polygon, and we have lots of different types of quadrilaterals based on angles and based on parallel sides. So this first one, I notice no right angles, so eliminate square and rectangle, but opposite sides are parallel, okay? But they're also not all equal, so he's not a rhombus. If they were all equal, he'd be a rhombus. Instead, he is a parallelogram. Next one, 4 sides, okay, quadrilateral. No right angles, so there goes square, there goes rectangle. I only have 1 set of parallel sides. 1 set of parallel sides in a quadrilateral has to be a trapezoid. Okay, 2 more. I've got 4 sides, so quadrilateral. I notice I got right angles. So right angles tells me it's either square or rectangle. But then I look at the sides. Opposite sides are congruent, but they're not all congruent. So by definition, he is a rectangle. Last one. I got my 4 right angles here. And all 4 sides are congruent. So there's my square. All right, let's get to some other polygons. First one, I notice he does not have all congruent sides, so he is not regular. He is irregular. And then if I count the sides, I see 1, 2, 3, 4, 5 sides. Remember that word for 5, pent. So he is an irregular pentagon. Next one, I notice all congruent marks, so he's regular. I count 1, 2, 3, 4, 5, 6. And remember, for 6, we've got hex, so he's a regular hexagon. All right, next one. I notice they're all congruent, so regular. I count 1, 2, 3, 4, 5, 6, 7. Remember, this is that tricky one. He's a heptagon. This last one, I don't see any congruency marks. I see what kind of looks like 4 sides, but what do you notice? Curves. Can it be a polygon if it has curves? The answer is no. So this guy I threw in there to try to trick you again. You know how I like to be. Not a polygon. Okay? Remember, don't assume. Use your mathematical knowledge that you know about shapes, polygons, all of those things when you are doing your independent practice. I do make mistakes. Sometimes I make them on purpose to see if you're paying attention. So, gentlemen, as you do your independent practice, do your best. If you have any questions, please feel free to email me or send me a message on Canvas. And I look forward to hopefully seeing you at our Zoom today when we're going to hang out with Mrs. Harris and the baby chicks. Very excited.